afternoon, pre-calculus kids. I say good afternoon because it is currently Monday afternoon, and I am recording this video to get ready for your Tuesday e-learning. So we're going to look at lesson 5.4 today, which is the last lesson that I have planned for us to look at before spring break. You will notice I already have the homework written on the screen. The homework, I say homework, but the problems assigned that go with this lesson will be on page 432, 11 through 14, 31 to 36, and 39 to 42. The recording of the lesson is Tuesday's e-learning. So your job on Tuesday is to watch the lesson, work to understand it, and copy the notes down. Your Wednesday e-learning will be on the problems over the lesson. You're welcome to do those early if you want, but that's my plan as of right now. No problems if you work ahead, though. And then as for Thursday, I'm going to see how things go here. Thursday we may just use as a catch-up day. I may come up with something else. I'm just kind of waiting to see how everything goes this week. So we are learning another set of identities. If I recall, I think it's actually the last set of identities that we really learn this chapter. And this is another set of identities it's good to be familiar with. Yes, they do come up in calculus some. So we have the double angle identities, power reducing identities, and half angle identities. So as we look at these, they all have their own special uses, just dependent on the situation. Your double angle identities, you'll notice that they are double angle identities because they are defined with 2 times the variables, sine of u to u, cosine of 2u, and tangent of 2u. So for the situations where you're not allowed to have 2 times the variable in there, there are other ways to rewrite them. For the power reducing identities, you'll notice these are ones that are squared, so sine squared, cosine squared, and tangent squared. And with those, notice when they are rewritten that they no longer have a power in them. It does give you a double angle in there, but it no longer has a power. And then our third set we'll be working with today is half angle identities. So you'll notice with the half angle identities, they are defined as having the u over 2 in them. So it's a variable divided by 2. And we will also learn how to work with those. So I have 4 examples. There's a lot, I'll warn you, there's a lot to do with these examples that we're going to work through that will at least be similar to some of homework. I may have to go back and give you a little more direction on homework, but I want to get through these basic notes first. So example 1, if sine of theta is equal to 4/5 and cosine of theta is less than 0, we are being asked to find sine of 2 theta, cosine of 2 theta, and tangent of 2 theta. So, first of all, hopefully you can identify that we will be using the double angle identities. We're being asked to find sine, cosine, tangent of 2 theta. We are provided sine of theta. And as you look up in your double angle identities, besides sine of theta, depending on which ones we use and where we're at, we're going to also have to know cosine and tangent of theta. So I'm actually going to start with that in finding our sine and cosine. Now, before we get started, sine of theta is 4/5 and cosine theta is less than 1. I want to draw a triangle to help us, but first thing I need to know is what quadrant are we in? So when I talk about what quadrant are we in, are you visualizing with me? All students take calculus, or if you prefer the variation, Amy Sargent teaches calculus. Okay, so sine is positive, and if sine is positive, then that means we either have to be in the all or sine. We can get rid of the bottom 2 quadrants. Cosine less than 0. What does cosine less than 0 say? And that says that cosine is negative. So now I need to be in a quadrant where sine is positive but cosine is negative. And that's going to happen there in quadrant 2. So as I draw a triangle that represents sine of theta equals 4/5, I'm going to draw this triangle in quadrant 2. So right here, that is my x and y axis. And remember, when you draw these triangles, that the hypotenuse is going out I'm going to undo that for a moment. I don't like how I drew that. The hypotenuse is going out from the origin. Remember, your theta is always between the x-axis and that angle. And so as I drop a perpendicular there and make my right angle, sine is 4/5. So what's my phrase I need to know for sine? I'm writing it up here right now. SOHCAHTOA. Sine is opposite over adjacent. So if sine is 4/5, opposite is, did I just say opposite over adjacent? I think I did. Gosh, sine is opposite over hypotenuse. So opposite, my angle is 4, and my hypotenuse is 5. So we know that sine is 4/5, and those are my pieces. I need to find my bottom side of this triangle. And so we know x squared plus y squared equals r squared or h squared or whatever you want to call it. So if we do 25 minus the 16, we're going to have 9. The square root of 9 is 3. And so then that means this side is a 3. Because we're in the second quadrant and we're going left, that 3 is a -3. I'm hopeful that is some good old chapter 4 review for you. So let's write down what we have here before we go into the next set of, or actually finding these. We're given that sine of theta is 4/5. Now that I have a triangle, can you tell me cosine of theta? Remember, cosine is adjacent over hypotenuse. So adjacent over hypotenuse is going to be -3/5. And we need tangent of theta. Tangent is opposite over adjacent. And so that's going to be 4 over -3. Or in other words, -4/3. So that's just kind of my prelim information there. Just trying to find what we need. And now, let's actually use our identities. So, first we're asked to find sine of 2 theta. Check your identities out up above, and it says sine of 2 theta is 2, up there it's in U's, so it says 2 sine U cosine U. So we're going to be doing 2 sine theta cosine theta. At this point, substitute your information in. 2 is 2. Sine of theta is 4/5 times cosine of theta is -3/5. So 2 times 4/5 times -3/5. The 2, if you want to make a fraction, is 2 over 1. And I don't see any cross canceling. So 2 times 4 is 8 times -3 is -24 over 25. So this is -24 25ths. And that is your sine of 2 theta. Next, we're asked to find cosine of 2 theta. As you look up above, you will notice cosine of 2 theta shows 3 different definitions. And it is actually up to you which one you use. If used properly, all 3 will work out the same. And so it does not matter which one you use. I'm just going to use the top one that says cosine squared theta minus sine squared theta. I'm trying to leave room because I still have to get my tangent one in eventually. So cosine squared minus sine squared means I'm doing -3/5 squared minus 4/5 squared. So I'm going to have 9/25 minus 16/25. And 9/25 minus 16/25 is going to be -7/25. And that is cosine of 2 times theta. One more. and that is tangent of 2 theta. Okay, so first of all, we need to get our definition. Notice tangent of 2 theta is a fraction. So tangent of 2 theta is going to be 2 tangent theta divided by 1 minus tangent squared theta. As with the others, substitute in the given information. So I'm going to have 2 times tangent theta, which is negative 4/3, divided by 1 minus tangent squared, so negative 4/3 squared. And from here, of course, it is simplification. 2 times negative 4/3 is going to be negative 8/3 divided by 1 minus 16/9. So if I do 1 minus 16/9, 1 in terms of ninths is going to be 9/9. So 9/9 minus 16/9 is negative 7/9, if you will. So I now have negative 8/3 divided by negative 7/9. Remember, to divide fractions, we're going to multiply by the reciprocal, or keep, change, flip. So negative 8/3 times negative 9/7. My 3 and 9 can cross cancel, become a 1 and a 3. I have 8 times 3, which is 24, over 1 times 7 is 7, and negative times a positive is a positive. So you should end up with 24/7 in reduced form. And that is my tangent of 2 theta. Okay, guys. So the double angle identities, not too difficult to use. It's a matter of setting up your triangle in the beginning so you have all the entry information you need, and then going from there. Okay, example 2 is asking us to rewrite cosine to the 4th x in terms of trigonometric functions with no power greater than 1. So if we're talking no power greater than 1, we are trying to do what to our power? We're trying to reduce our power. And so this is going to be a situation where we are trying to use the power reducing identities. So we are starting with cosine to the 4th of x. So this is more a exercise in more of like a simplifying or proving. We've done something similar to this previously. So cosine to the 4th x, we want no power greater than 1. Do we have an identity for cosine to the 4th? And you'll notice, no, we do not. We only have an identity for cosine squared. So how can I rewrite cosine to the 4th but using squareds? And hopefully you'll realize cosine to the 4th would be the same as saying cosine to the 2nd and then squared. So I'm going to write that as cosine squared x squared. Now, fill in your identity. What is the identity for cosine squared? And the identity for cosine squared is 1 plus cosine 2x divided by 2. And then that's going to be quantity squared. We need to do a little simplifying here. And as we simplify, notice on top we have a binomial. Since we have a binomial on top, that means how do you multiply a binomial times a binomial? You're going to have to FOIL. So we're going to FOIL that numerator there. So as I FOIL, first, 1 times 1 is 1, plus outsides and insides. So 1 times cosine 2x is cosine 2x, plus another 1 times cosine 2x is cosine 2x. 1 cosine 2x plus 1 cosine 2x is going to be 2 cosine 2x. Plus, and last, cosine 2x times cosine 2x. Well, cosine times cosine is going to be cosine squared 2x. All over 2 times 2, which is 4. Okay, so now our job is to write this with no power greater than 1. You'll notice we have a slight issue here because at this point we still have a power greater than 1. In that I have this squared power here, and I'm only allowed to have powers of 1 and nothing more. So this means we need to apply this identity again. Now, the trick when applying it again is that this time, instead of it being cosine squared x that we're starting with, you'll notice that we're starting with cosine squared 2x. And so that's where we're going to have to be very careful, because where it normally says cosine squared u, what is in place of u right here is 2x. And so it just means we're going to have to be careful when we rewrite here a little bit. Okay? So, how much do I want to do at once? Because that cosine squared formula is a fraction, I think I'm going to go ahead and split these up. Remember, this denominator of 4 right here is going to go with each numerator. So I'm going to split that up in that the 4 goes under the 1. So I'm going to have 1/4 plus the 4 goes under the 2 cosine 2x. But that 2 out in front of the cosine 2x with the 4 as a denominator, 2 over 4 is 2/4, which can reduce to the fraction 1/2. And so I'm actually going to write this as a 1/2 coefficient cosine 2x. And then plus. Now, my 4 goes under my cosine squared 2x, so I'm going to write it out front as a coefficient of 1/4. And now, we have to work with that cosine squared 2x. So again, go back and use the power reducing identity. Power reducing identity says 1 plus cosine, and it says 2u. Well, what is our u value there? Our u value, if you look, is essentially the 2x there. And so it's going to be 2 times the 2x that's already there, which means this is going to be 1 plus cosine 4x, all divided by 2 still. Okay, at this point, notice, do I have any powers greater than 1? And I do not. So at this point, it is just a exercise in cleaning up. I'm going to keep my initial part, the 1/4 plus 1/2 cosine 2x, plus, I'm going to keep this 1/4 out front for the moment, and then what's in parentheses in red there, I'm going to split up into 2 fractions. So I'm going to put that 2 into both denominators. So it's going to be 1/2, or in other words, 1/2, plus cosine 4x over 2, which in this situation I'm going to pull that 2 out front as a 1/2 cosine 4x. You notice we have parentheses with the 1/4 in front, so I am going to work to distribute here. I'm going to distribute that 1/4 to both terms. So first of all, I still have 1/4 plus 1/2 cosine 2x plus, now if I distribute 1/4, 1/4 times 1/2 is 1/8, plus 1/4 times 1/2 cosine 4x is 1/8 cosine 4x. Okay, almost there. We're at cleanup here. First of all, you will notice we do have two like terms that we can add. We can't add the cosine 2x and cosine 4x. However, I do have just two plain old fractions of 1/4 and 1/8. And so what is 1/4 plus 1/8? If we make them eighths, that's going to be 2/8 plus 1/8, or in other words, 3/8. Still plus 1/2 cosine 2x plus 1/8 cosine 4x. That is one possible way to write your answer. I can't remember exactly which way the book writes it, but I know I have in my notes that there's a second way. In that, if we want to clean this up and not have a fraction in each term, notice denominator-wise there's eighths and halves. So a common denominator would be an 8. And so a way we can do this is to factor out an 8th. If you factor out an 8th from 3/8, that still leaves me with 3. Plus, if I factor out an 8th from a half, well, what is a half with a denominator of 8? And you realize 1/2 is 4/8. So if I factor out an 8, I'm left with 4 cosine 2x. Plus, one more here. If I factor out an 8th from cosine 4x, I'm just left with a plain old cosine 4x. And that is another acceptable way to express your answer. They are equivalent, and it's just, I like being able to show you equivalent answers that may look very different, but yet both be correct. Okay, continuing along. So far you'll notice we've used the double angle identities, the power reducing identities, and now you'll notice that we are going to be talking about half angle identities. And this is going to be an example of just how to use the half angle identities. Excuse me. So, given that cosine of theta is 7/25 and sine of theta is greater than 0, find sine of theta over 2, cosine of theta over 2, and tangent of theta over 2. I'm going to start this example similar to number 1, and then I'm going to draw a triangle, and I need to know sine and cosine. I forget, do I have to know tangent? And as I look up at my half angle identities, which is what I'm going to have to use, I do not have to know tangent. So we just have to know sine and cosine. We already have cosine. We just now need to find sine. So I'm going to think about my triangles. Cosine of theta is 7/25. Sine of theta is greater than 0. That is saying that sine of theta is positive. So where are cosine and sine positive? And hopefully that is the easy answer. If sine and cosine are positive in quadrant 1. So if I draw my triangle in quadrant 1, so I'm going to draw my angle up here from the origin. Remember, theta is always between the angle and the x-axis. I'm going to drop my other side of the triangle. Cosine is 7/25. So if cosine is 7/25, remember cosine is adjacent over hypotenuse. So adjacent is going to be down here 7, hypotenuse is over here 25. We need to find our third side of the right triangle. And so you can do 7 squared plus y squared equals 25 squared. So 25 squared is what, 625 minus 7 squared, which is 49, puts us at 576. And the square root of 576 is 24. So if I write down my information that I'm going to need to know going forward, we already know, or we're provided, that cosine is 7/25. We also need to know sine theta. Remember, sine is opposite over hypotenuse, which is going to be 24/25. And I think that's all the information we need to begin this problem. So, sine of theta over 2 is what it asks us to find. Sine of theta over 2, we have a definition, which according to the identities up there, plus or minus the square root of 1 minus cosine theta over 2. So, start filling it in. Now, first of all, plus or minus. Sine of theta divided by 2. Well, sine of theta was in what quadrant? And you'll notice that sine of theta was in quadrant 1. If you take theta and divide it by 2, what quadrant are we going to be in? And you'll notice that we're still going to be in quadrant 1 here. So you can go ahead at this point and drop off the plus or minus if you want, and just realize that in this particular problem, all my answers are going to have to be positive. If we were in another quadrant, we would have to pay attention to the signs in that quadrant. So this is going to be the positive of 1 minus cosine theta, which is 7/25, all over 2. And that's all under the square root there. As I do work to do some cleanup, 1 minus 7/25. Well, 1 with a denominator of 25 is 25/25. Minus 7/25 is going to be 18/25. Now, officially, I'm not going to write it, but I have 18/25 divided by 2. Dividing by 2 is multiplying by the reciprocal 1 over 2. So I'm going to write that as times 1/2. So I have the square root of 18/25 times 1/2, which, when I multiply 18/25 times 1 over 2, my 2 and 18 can cancel. I have the square root of 9/25, and the square root of 9/25 is 3/5. That is my sine of theta over 2. We can follow the same process with my other two identities. So we're also asked to find cosine of theta over 2. The rule for cosine of theta over 2, or the identity, says plus or minus the square root of 1 plus cosine theta over 2. Again, fill in the pieces. Remember, we're in quadrant 1. All angles in quadrant 1 will be positive, so I can drop off the negative. This is a positive 1 plus, and this time it's plus cosine theta, so 1 plus 7/25, all divided by 2. If I do 1 plus 7/25, 1 as a fraction is 25/25. 25/25 plus 7/25 is going to be 32/25. Divided by 2 is multiplying by 1 over 2, so times 1/2. And again, clean it up. 32 over 25 times 1 over 2. The 2 and 32 can cancel. I have the square root of 16/25, which is 4/5. One last one to work on here, and that is our tangent. So we're going to do tangent of theta over 2. Check out that definition. This one's different. The definition here is sine u over 1 plus cosine u. So since we're using theta, I'm going to say sine theta over 1 plus cosine theta. Sine theta is what? 24/25. So I'm going to have 24/25 divided by 1 plus cosine, which is 7/25. So I now have the 24 25ths divided by 1 plus 7 25ths. So 1 here with my common denominator is 25 25ths plus 7 25ths is 32 25ths. Fraction divided by fraction, we want to multiply by the reciprocal. So I'm going to have 24 over 25 times 25 over 32. If you do a little simplifying here, 25's cancel. 24 and 32 can both divide by 8, and I will have 3/4. And that is tangent of theta divided by 2. Okay, so that we have used the double angle and half angle identities. I've shown an example of simplifying with the half angle identities, or excuse me, with the power reducing identities. And I want to do something a little different with example 4 using the half angle identities. And using the half angle identities to find the exact value of sine of 3 pi over 8. Now, I do remember you have this one to work on homework. Notice it says exact. Exact means I do not want the decimal answer the calculator spits out, but I want an exact answer. It means it has fractions, it probably has square roots in it since we're working with trig functions. And that's where we're going to start. So first things first, we are trying to find the exact value of sine of 3 pi over 8. Now, as we work to find the exact value of sine of 3 pi over 8 using a half angle identity. So half angle identities read sine of something divided by 2. And so here's what I'm trying to show you, is that I want sine of 3 pi over 8 to equal something divided by 2. So I need 3 pi over 8 to be something divided by 2. So let me do a little side note here. Something divided by 2 needs to equal 3 pi over 8. So think about this. If it's something divided by 2 equals 3 pi over 8, dividing by 2, the opposite is 2 times by 2. So the point I'm trying to make is that always, to find the piece I need, we're going to multiply by 2. So when I take 3 pi over 8 and I multiply by 2, I'm going to be at, if you simplify it, 3 pi over 4. And that 3 pi over 4 is what's going to go in up here on top. Okay? So always to start with your half angle identity, take the given that you're trying to find the exact value of 3 pi over 8 and multiply that by 2. Because now, since I've multiplied it by 2, 3 pi over 4 divided by 2 is equal to 3 pi over 8. Okay, so we're going to use our half angle identity. The half angle identity for sine says plus or minus the square root of 1 minus cosine of u divided by 2. What is my u value? If this was for the sine of u over 2, you will notice my u value was what I put in right here, what we found. So my u value is that 3 pi over 4. So that is the expression we need to work on simplifying. I'm going to keep the plus and minus right now. And then we'll talk about the end, whether it's positive or negative. Square root of 1 minus. What is the cosine of 3 pi over 4? So first of all, I hope you have your unit circle close. 3 pi over 4 is a multiple of pi over 4. So first of all, what is the cosine of pi over 4? And the cosine of pi over 4 is square root of 2 over 2. 3 pi over 4, though, is in quadrant 2. And what do we know about cosine in quadrant 2? All students, so that sine is positive, everybody else is negative, so cosine is negative. So cosine of 3 pi over 4 is negative square root of 2 over 2. So my expression right now is plus or minus the square root of 1 minus the negative square root of 2 over 2, all divided by 2. So, it comes down to more cleanup. I'm keeping my square root for the moment. First of all, what do we know about minus a negative? And minus a negative is going to be plus a positive. So, and this 1, I guess let me back up. What I want to do is I want to add my numerator. What is 1 plus radical 2 over 2? And when I say what is 1 plus radical 2 over 2, so what is 1 is a fraction with a denominator of 2. And that is 2 over 2. So what's 2 over 2 plus radical 2 over 2? And hopefully you are with me and realizing that is 2 plus radical 2 all over 2. Now, the one thing I haven't dealt with is that 2 in the denominator. This 2 in the denominator is dividing by 2. Dividing by 2 is multiplying by 1/2. And so I have a times 1/2 right there. Continuing along, I still have plus or minus the square root, 2 plus square root of 2 on top. When I multiply my denominators, well, my numerator, when I multiply by 1, it stays. When I multiply by denominators, 2 times 2 is 4. Now, that's all one square root. I can't really do anything with the numerator, so it's going to stay plus or minus the square root of 2 plus square root of 2. However, the denominator is 4, and the square root of 4 is 2. So better form is to pull that 2 out of there. Okay. One last thing. Plus or minus, which is it? We were asked to find the exact value of sine of 3 pi over 8. And where is sine of 3 pi over 8? Where is 3 pi over 8, I guess is what I'm asking. And 3 pi over 8 is in quadrant 1. And since that's in quadrant 1, what do we know about quadrant 1? Quadrant 1 is positive. So, final answer here that I'm looking for is square root of 2 plus square root of 2 all over 2. Or, the other option is if you take that 2 out of the denominator and pull it out front, it's 1/2 and then times this whole square root of 2 plus the square root of 2. Again, both are good answers, just depends on the situation there. Okay, guys, that is your Tuesday lesson. Wednesday is to give the homework from it a solid attempt and see what you can do with it. I hope you guys are staying safe and keeping up with your work. I'm going to be starting to work to contact a few of you that I haven't seen any homework from and make sure you guys are with me. Hopefully you're finding ways to connect to Wi-Fi and everything in this unique time. I will talk to you guys later. Bye.